Okay, let's unpack this. Imagine you've just finished a big, complex upgrade on a piece of machinery you rely on.
Yeah.
You powered it up, tested it, everything looked great. Days go by, then weeks, 25 days, to be exact, without a single hiccup.
Mm-hmm. Feeling pretty good at that point.
You're feeling good, job well done. And then, suddenly, out of nowhere, weird things start happening.
Uh-oh.
Not related to the upgrade itself, it seems, but triggered by something totally different. Like plugging in a USB stick. Random alarms flashing.
Oh, that's the kind of problem that makes your stomach drop. It's intermittent, tied to a common action, but the alarms are unpredictable. You think, what on earth changed?
Exactly. And that's the specific technical rabbit hole we're diving into today. We're looking at troubleshooting a really strange issue. Random alarms popping up on an Okuma OSP-P200L machine after a panel computer upgrade.
Specifically when USB devices were inserted, yeah.
Right.
And the cool part is our source material isn't some dry report. It's the actual messy, real-time WhatsApp chat log from the maintenance team who lived this problem.
So we get to see their process unfold.
Yeah, it's their minute-by-minute process, their theories, their frustrations, and, ultimately their surprising discovery.
So our mission for this deep dive is to follow their conversation thread, piece together the clues, see how they navigated the troubleshooting maze, and figure out what seemingly unrelated detail turned out to be the culprit.
Let's do it.
All right, let's jump into the chat log. It opens on April 22nd, 2025. The team is focused on the Okuma OSP-P200L machine on the BLD B8W line.
Okay.
Specifically installing a new panel computer, upgrading from a PNC2 to a PNC4.
Right there at the start, the chat confirms the upgrade was finished and the machine tested on April 22nd. Looks like the initial swap went smoothly on the surface anyway.
And they had their follow-up plan. The next day, they were going to create a ghost image of the CFS memory, essentially cloning the machine's brain.
Standard procedure,
Backup. And upload it for backup, exactly.
Yeah.
Standard procedure.
What's really striking when you look at the chat timeline is what happens after April 22nd. There's this long silence regarding any issues with the machine.
A big gap.
Yeah, the conversation related to this specific problem doesn't pick up again until like the middle of May.
And the log explicitly states the machine ran without reported problems for 25 to 26 days during that gap. That's a huge context, right?
It absolutely is. It immediately suggests the problem wasn't a fundamental failure of the upgrade itself on day one.
Makes sense.
If the new panel or the basic install was bad, it should have failed much earlier. The issue was either triggered later or maybe developed over time. This 25-day gap was a critical clue that narrowed their thinking right away.
Okay, so after this long period of smooth sailing, the mystery finally surfaces around May 15th or maybe May 18th, depending on who's reporting it in the chat.
Yes, the core problem appears. Inserting any USB device into the panel computer, a flash drive, a mouse, they even mentioned trying a portable DVD player.
Wow, anything.
Caused different, seemingly random alarms to pop up on the Okuma control software.
Random alarms just by plugging something in? That sounds incredibly frustrating and really hard to isolate.
Totally.
And there's a key detail Juan points out early on. This only happens when the Okuma OSP software is running. If they just had the panel booted into Windows XP, inserting devices worked fine, no alarms.
That right there tells you the problem is happening at the layer where the OSP control software interacts with the Windows operating system and its hardware.
Right.
Specifically the USB subsystem. It's not like a broken USB port in a fundamental sense if it works okay in plain Windows.
So before bringing in more people, what were the first things the team tried, the initial steps?
Well, Juan describes going through the basics, testing different USB devices, make sure it wasn't just a bad stick.
Standard stuff.
Confirming the issue happened on both the upper and lower USB ports, physically checking, and even replacing the USB port component itself. Problem still there.
Even replacing the port didn't fix it, huh?
Nope. They tried updating the USB driver, but it was already the latest version available. And they performed a backup and restore of the NC data, which is kind of like a soft reset of the controls configuration.
Right, see if some setting got corrupted.
But again, no change. Still getting those random alarms.
So they're systematically eliminating the obvious. The device, the physical port, the basic driver, the NC data. This is when Fabian gets pulled into the detailed troubleshooting around May 22nd.
And his first reaction is all about process, documentation. He immediately asks for the troubleshooting logs.
Of course.
Were they saved? Can they be shared? He emphasizes how critical they are for these complex issues and asks for the machine's history as well.
It's hard to troubleshoot effectively without all the breadcrumbs, right? Those logs are key.
Defo.
There was also a brief chat about communication channels email versus the dedicated WhatsApp group.
Yes, and the consensus was, keep these critical troubleshooting discussions for upgrades and retrofits in the dedicated group. Easier for everyone involved to track the conversation and history.
Makes sense. Keep it all in one place. Now, based on the symptoms, random behavior tied to USB and the Windows interaction, Fabian starts listing potential root causes.
He considered things like an incorrect Windows OS installation, or maybe a missing difference installation RK for P200, which is specific Okuma software.
Okay.
But remembering that 25-day smooth run, he could immediately rule those out as the primary culprits.
Because it worked fine for so long.
Exactly. That's a crucial insight driven by the timeline. If the OS or core Okuma installation was fundamentally wrong, the machine shouldn't have worked for nearly a month.
Good point. Good point. So where did that leave the focus then?
It zeroed in on things like specific USB driver issues on the PNC4, maybe potential OSP software incompatibility or configuration errors that weren't immediately apparent.
Stuff that might have emerged later.
Right. Or faulty USB hardware other than the port itself, or maybe something going wrong with the CF card after the initial installation and cloning.
Okay. So still several possibilities.
Yeah. And the immediate action plan was get the logs, review the history, make a detailed plan, and schedule more machine time to test.
Standard troubleshooting flow.
Exactly. Those logs were finally shared the next day, May 23rd, which hopefully contained some error messages or, some clues.
Fast forward a bit to May 28th. Jose asks Juan to list the steps taken so far, just to get a clear picture for everyone jumping in or reviewing.
Yeah, quick recap.
It's the same list we just went through. Testing USBs, checking Windows-only mode, driver updates, port replacement, backup restore.
And Juan confirms the next major step they were planning was to replace the entire control panel itself.
The whole thing.
Put in a whole new PNC4 panel to see if the original upgraded panel was somehow defective, despite working initially.
Okay, so on May 30th, they decide to do the panel swap. They install a brand new PNC4 panel. This seems like a solid troubleshooting step to isolate if the issue is with the physical panel hardware.
It is. A big step, but logical. But then, there's a moment of confusion captured in the chat. After installing the brand new panel, they still saw issues.
Oh no, after all that work, what happened? What went wrong?
Well, they realized they had accidentally left the original CFast memory card from the April 22nd upgrade day inserted in the new panel.
Oops.
Instead of using the cloned CFast card that had been running the machine for those 25 days.
So they swapped the hardware but used the old brain from before the operational period. That's easy to see how that could cause issues. Not a true test.
Right. Fabian points out that even though they were both PNC4s and the cloned ones started from the original, operational data changes over time. Using the outdated CFast on the new panel wasn't a like-for-like test of the current operational state.
Makes sense.
They quickly corrected this by installing the correct cloned CFast that had been in the machine.
Okay, so by the end of May 30th, they have the brand new PNC4 panel installed with the correct operational CFast memory. The machine goes back into production.
And Fabian makes a key observation at this point. Definitely seems to be a software issue.
Even with the new panel.
Yeah, the panel swap, even with a brand new unit and the correct memory, hadn't immediately solved the mysterious USB problem. This reinforced the idea that the panel hardware itself probably wasn't the primary culprit.
Interesting. So the problem persisted even with entirely new panel hardware.
Right. They were even making plans to rework the old panel, the one they just took out, either offline or scheduling hours of downtime.
Thinking maybe the original upgrade process was flawed somehow?
Exactly. Because the focus was shifting back to configuration or software installation issues, not faulty hardware per se.
And this shift in thinking leads them to look even closer at the hardware configuration, specifically comparing the old PNC2 setup to the new PNC4 setup.
And a crucial hardware detail surfaces. The original panel was a PNC2 15HQI V1.UI, part number A9013302. The new one, the PNC4, is part number A9113360.
Different generations, different part numbers.
Different generations, different internal layouts, potentially.
Yeah. Okay, but the real breakthrough, the surprising fix, comes to light on June 3rd. It wasn't the panel or the CS or the USB port itself. It was a different board, the DeviceNet board, model PCI-SVDN1.
Yes, and the key wasn't just the board's presence, but its physical location in the PCI expansion slots within the panel computer.
The slot position, how could that possibly matter? That seems minor.
Well, it turns out it mattered a lot. When this DeviceNet board was installed in the third slot, which was the configuration they had after the upgrade,
The one causing problem.
the system assigned it a specific memory range and, critically, an interrupt request, or IRQ, of 07.
And that's when inserting USB devices caused all the random alarms. IRQ 07.
Precisely. Now here's the part that makes you scratch your head. The diagnostics for that PCI-SVDN1 card when it was in the third slot with IRQ 07 reported no conflict CTS.
What?
The system's own checks said everything was fine with that configuration.
Wait, the diagnostics said everything was fine, but the machine was clearly not fine, throwing random alarms. That's crazy. How can that happen?
It highlights how diagnostics can sometimes miss subtle interactions. The system might see resource A assigned to device X and resource B assigned to device Y and think, no conflict.
On paper, it looks okay.
Right. But the way those resources are accessed or the timing involved can still cause issues in complex interactions, like between the OSP software, the USB subsystem, and this DeviceNet board in that specific slot.
Okay, so if diagnostics weren't the direct path, how did they figure out it was the slot? Did someone just remember the old setup?
The chat suggests they eventually look back at the original PNC2 configuration. Where was that DeviceNet board plugged in before the upgrade?
And it wasn't slot 3.
It was in the first slot.
So the simple fix was move it back to the first slot. After all that.
That's exactly what they did. They moved the DeviceNet board from the third slot back to the first slot.
And what happened? Did the IRQ change?
Yes. When the board was moved back to the first slot, the memory range assigned to it stayed the same, but the interrupt request changed. It went from IRQ 07 back to IRQ 05.
And with the board in the first slot and the IRQ at 05, the problem disappeared.
Yes, completely gone. Placing the DeviceNet board back in the first slot, which resulted in the system assigning it IRQ as 05, resolved the issue entirely.
Wow.
They confirmed it by plugging in various USB devices, a keyboard dongle. Everything worked perfectly with no alarms on the CNC.
Wow. So after testing devices, ports, drivers, software, and even swapping the entire panel, the solution wasn't a faulty component or a major software bug in the way they initially suspected.
Nope.
It was literally which physical slot a different board was plugged into, because that changed a system-assigned resource like an IRQ.
That's the core technical takeaway. The issue wasn't hardware failure or straightforward software incompatibility. It was a resource conflict, specifically related to the interrupt request assigned to the DeviceNet board.
Dictated by the physical slot.
Exactly. That IRQ assignment was dictated by the physical PCI slot the board was in. IRQ 07 caused the conflict when interacting with the USB subsystem under OSP. IRQ 05 didn't.
And the fact that diagnostics missed this conflict when it was in the third slot is genuinely surprising. Makes you wonder about the limits of those tools.
It is. It really underscores that system behavior can be incredibly complex, affected by interactions that go beyond standard resource conflict checks.
So the major lesson here is, what's the big takeaway?
This case screamingly highlights the critical importance of meticulously replicating the original hardware configuration and physical layout when performing hardware upgrades.
Don't just focus on the part you're swapping.
Exactly. It's not just about putting the new component in. It's about ensuring all the other components and their positions match the known good configuration as closely as possible.
Don't just swap the main part. Pay attention to where every cable, every board, every small piece was before you touched anything. Seems obvious, but clearly easy to overlook.
Precisely. Minor differences in physical slot placement can have these cascading effects on system resource allocation, leading to incredibly difficult to diagnose anomalies that standard tools might not detect.
So what happened right after the fix? Confirmation.
On May 31st, the very next day after moving the board, Juan confirmed the machine was running well and explicitly tested the USB devices again.
The moment of truth.
Verifying that they worked without triggering alarms must have been a huge relief for the whole team.
I can only imagine. Weeks of frustration solved by moving one card. And did this experience lead to any other process changes, beyond just being careful with slots?
Yes, the issue also highlighted some practical needs around parts management. They realized they needed better SAP coding and procurement processes for the new PNC4 panel itself, and perhaps more importantly, for that specific DeviceNet SVDN1 board.
Ah, so they could find and replace it easily if needed.
Right. If a simple swap or repositioning is needed in the future, they need those parts codified and readily available.
Makes total sense. And better documentation, I assume.
Absolutely. Work is underway to create detailed failure analysis documents for this specific event and to list all critical CNC components that need to be properly codified and tracked within their system going forward. Lessons learned leading to process improvements.
Good outcome from a tough problem. So, to wrap up this fascinating journey documented in a WhatsApp chat, we started with a smooth upgrade that ran perfectly for almost a month.
Seemed like a success.
Then, a completely unexpected problem emerged: random alarms when using USB devices only when the Okuma software was active.
The team went through all the logical troubleshooting steps. Verifying devices, testing ports, checking drivers, basic software resets, and even the significant step of swapping out the entire new control panel itself. Still no fix.
And after exhausting those options, the solution wasn't replacing a faulty part they had installed, but realizing that a different board, the DeviceNet board, was in a different physical slot than it was originally.
Moving that DeviceNet board back to its original slot changed the interrupt request the system assigned to it, from IRQ07 to IRQ05. That subtle change in resource allocation fixed the problem.
Even though system diagnostics had reported no conflicts in the problematic configuration. Just amazing.
Yeah.
It's a powerful reminder of how complex and sometimes counterintuitive integrated technical systems can be.
Indeed. The why isn't always obvious, and sometimes the fix lies in these unexpected, seemingly minor details.
So for you listening, think about this case. What other seemingly minor details in the systems you work with, whether it's a complex manufacturing line, an IT network, or something else, could have profound, hard-to-diagnose impacts even when standard checks tell you everything is fine? What does this story tell us about the absolute necessity of meticulous documentation, understanding original configurations, and paying attention to minute physical details in any technical field? It might just save you from a multi-week troubleshooting nightmare.